So, hi, hi everyone. Today I'm recording this video in order to explain of um, what's the state of the art in natural language processing and where are we at the moment in order to understand how to apply concepts of natural language processings into our applied science-based tasks. And is the deep learning side of natural language processing all what's there into doing things, or can we leverage the classical models for our own good when according to the situation in which they have to be applied? So stay tuned. In principle, one of the topics which I'm kind of looking nowadays is into document classification. So there'll be actually a chunk of document, and you need to classify whether it's a title page, whether it's a not a title page, whether it's a follow-up page or a miscellaneous page, and then if it's a title page, then which class does it belong to, and whatnot. Going by this problem, I've kind of seen various approaches being taken for this particular problem, and all of those has got their own merits and demerits. But what's the preferred way of attack? I mean, the preferred way of solving this problem, and how should one think of doing so, is what I'm gonna discuss in this video. In particularly, and basically, I'm doing nothing, I'm not discussing, I'm just showing you thoughts which come to my mind when I see a problem like this. First up, what are the inputs? The inputs are basically chunks of data in terms of documents, that is PDFs. And such PDFs clubbed into certain folders, and the folders are actually the classes. Like, let's say PDFs of mythology. So there'll be a folder called mythology, and then there will be several books of mythology in each of these PDFs. In each of these folders, like several books of mythologies all around the globe. Doesn't matter. Then epidemiology. So I should know how to pronounce that. Of course, after COVID, I should. Never mind. So several books of epidemiology in that particular folder, and so on and so forth. Many folders, many PDFs inside each of these folders. So what should be any way of solving this problem? How would one attack this problem? Take your time, pause the video, think. So what you want to do is, I hope I think you would have come to a conclusion about, we need to first define what the input is and what the target is. Then only we can have a black box solve this thing, right? What the black box can contain? The black box can contain a machine learning model, or a statistical model, or a probabilistic model, or the last case would be a deep learning model. And in deep learning as well, there will be many caveats. And the last caveat, which should be, this is the state of the art model, which would involve some kind of transformer or some application of transformer. So this is the whole overlay of things, how things would work on. By the way, I missed one particular model which can also be there in the black box, and which actually helps us think of solving this problem. And that model is nothing but a human. So first we need to think how a human would solve this problem. I mean, given an infinite time and infinite resources, how a human would solve this problem. This idea of how human will solve this problem will help us understand the core concepts and to build a model. I know there are a bunch of models already on Hugging Face or everywhere on the internet which can solve this problem in seconds. I mean, so they are pre-trained model and you will be just doing inference. But I'm not talking about this particular problem. I'm talking about a problem in general. How to solve a problem in general. The first and foremost thing for you to understand is how a human would solve this problem. And then on only, we kind of break the problem into sub-problems and solve these sub-problems step by step. Then we either make or fail in these challenges, and then we kind of move on towards a more complex model or a model which has less bias. So what is bias and why am I saying about the bias? Apparently a model with a lot of assumptions is usually a simpler model, but in terms of machine learning caveats, we say it's a highly biased model. That is, it's highly biased towards our assumptions. I mean, you can just search for it, like which models are biased in which ways. Just to give an example, a convolutional neural network model, which is in a sense a deep learning model, is heavily biased towards the translation invariance of images. So, and then there are like a variety of models which have certain biases. As we get more biases, it becomes a simpler model. The less bias we have, it becomes very complicated to think. So first we need to have a certain bias. What can be the bias? The bias can be, for this particular case, the bias can be, let's assume certain things. So bias comes with assumptions. Assumptions are, let's say all the title pages would have a word called title. Now this is a bias. Now, how to inculcate this bias in the model? This is where the thinking evolves. How to include this bias in the model? So what my brain says is, hang on, why don't we just hard code this, that, okay, if it has the word title, then it becomes our title page. Now this, I mean, you can anyway think that even a follow-up page may have this word title, right? So this is an idea which is going to fail, but still, I need to propose the thing that how to implement this idea of like title is there, then it's a title page. This can be done when we kind of extract the texts from the PDFs and then search the text, the particular text called title in those PDFs, in those texts of the PDFs. If and then have an if-else statement, whether or not it's there or not there. Now, when we have an if-else statement like that, it becomes a hard-coded model. It's not a model which is learnable in any sense. But the bias term which we were like discussing was a kind of was kind of a notion of a machine learning model. So, what would the occurrence of word which is title mean in a machine learning model? Now this is my second question. Think about it. Like, how would you convey a model to think like, okay, yeah, there is a word title, then it's a title page. So whenever we are into the realm of machine learning, the question, it is a title page, would convert into it may be a title page. That is forming a probabilistic scenario of our interpretations or our assumptions. Once we form a probabilistic scenario, it can be then well represented by the state of the art, not the state of the art actually, but the current machine learning models. So next I'll cover later.